Can you guys all see my screen?
Yes.
Okay, cool. All right, so I'm gonna go ahead and get started. I'll introduce myself in a second, and I'll introduce my co-host in a second. But here, today we're here to talk about AI-powered lean or AI-powered production. And this idea that when you have a large data set, manufacturers can improve manual operations at a scale that's never really been possible before. Now, this is a COVID webinar, which means I'm at home, which means you never know what's gonna happen. The gardener could go by, my dog could come running in and bite my leg. So we'll just see how that goes. I'm going to start with the story though, and then throw it over to Samir to talk about something that he saw at one of our customers. So on July 3rd, 1995, I went to Coors Field as a recent high school graduate in Denver and saw this guy, Andres Galarraga, play one of the best games of his life. It was versus the Astros, and he went 6 for 6. He hit 1,000. It was an extraordinary game, and I bring this up because in a lot of manufacturing environments, you have to make very significant decisions based on very little data. So for example, if I was measuring Andres and trying to predict his output for the year based on the data that I observed, I would have predicted he would hit 1,000 because I had no reason to think that he would not hit every single pitch thrown at him that year based on the observations I'd performed. Well, the reality, of course, is very different. The entire season, he went about 280, not bad, but certainly not 1,000, which is, I think, a good segue to hand it over to our first story about what we're observing when we deploy AI-powered lean. And by the way, we're doing this webinar a little bit differently. Typically, it's here's an introduction, here's the beginning part, middle part, end part. We're going to try to intersperse this webinar with stories that we're seeing to try to make it a little more interesting and switch it up a little bit. So Samir, over to you, and then we'll do some introductions.
Absolutely. So this shows actual data points that Drishti collected on one line at its customers. There's 10,000 data points here. The dotted line is the mean cycle time. So this is each point represents, excuse me, one cycle on the line, and the dotted line is the mean of the cycle times. Now, we spoke to the IEs and tried to replicate their sampling methodology to actually measure. So Dave, if you could click. Mm-hmm. And so we generated 10 different sets, I think 8 different sets of potential cycle times they could measure using their technology. So firstly, you can see that they all vary. The second thing you can see is all the means come in, or most of them come in under the actual time. And with Drishti, because we're continuously and automatically measuring all the cycle times, we can actually tell you what the true mean on the line is. And the true mean on the line actually is none of those numbers, and it's higher than all of those numbers. It's in fact 315 seconds. And the story here is any one typical data measurement that you make using an industrial engineer will give you an incomplete and often incorrect picture of the line. And this does not even account for the fact that when an industrial engineer is standing behind an operator taking a measurement, you're going to get a biased observation. They might work faster if they think that their boss is watching, or they may work slower because they may think that if that allows them to set up a lower standard that they can beat later. So we avoid the bias and we give you enough data to make real measurements.
Yep, cool. Thank you. So that being said, I'm going to now explain to you who's talking. So I'll start. I'm Dave Prager. I'm going to moderate the webinar today. I'm the head of marketing here at Drishti. I've been with the company since we were a 2-person company. As we'll talk about in a second, we're a 50-person company-ish today, and a lot of really interesting things happening on our side. Samir, do you want to introduce yourself?
Yeah, absolutely. So I'm Samir Gupta. I'm the head of customer solutions. I joined Drishti just over 2 years ago. And for the last 2 months, I have been running customer solutions. But prior to that, I was also running Drishti's data team and have been responsible for a lot of the analytics we have built. Currently, I work on working with our customers to explore use cases, value, and ROI.
Great. And Primo?
Hey, good afternoon, everyone. My name is Primo Garcia. I am the customer experience advisor. I'm the person who would work with you, the customer, directly in deploying Drishti in your facility on a given line or multiple lines. I am that guy. Previous to Drishti, I've been here with them just over a year and a half. And previous to Drishti, all my experience was the manufacturing engineer who was setting up the lines, establishing what the line's going to look like, what it's going to, reviewing the line once it's been deployed, and figuring out all the bottlenecks and all that kind of good stuff. So now I get to see it on the other side as far as what Drishti can offer customers, and it's invaluable. It really is. It's night and day difference.
Cool. And we'll get back to that in a second. But I think the broader point here is this idea that Lean today has evolved in a certain, let's call it a vacuum of data. And a lot of the job of people like Primo in their old lives was just to stand there with the stopwatch and get the data. Suddenly, technology like Drishti and other kinds of technology are coming along where there's data continuous. Streams of data that you've never had before. And the idea is, how does it change Lean? How does it change production? And what do the roles of people in operations and quality and management, how do they change along with it? So this is the agenda for today. We're gonna talk a little about the state of Lean today. We're gonna talk about what AI adds to it. And then we're gonna tell you along the way, 5 stories of using AI-powered production or AI-powered Lean to solve really perennial manufacturing issues. And these are stories that come from our customers. Like Primo said, he is one of our many customer experience representatives who are there working with customers day in, day out to use the data and use the tools to make better decisions. Just 2 minutes about what Drishti's doing. So the question is, if I wanted to go and improve a line, it's a known methodology to go station by station, process by process, step by step to make change. And there's a proven science in eking out those 1%, 2% incremental improvements at this station or that station. And we've all had that experience where we get very excited about a 3% improvement in product in throughput, or 2% reduction in the defect rate or something like that. But that doesn't work anymore because we're certainly in these days of COVID where everything's changing every day. The business is taking massive shifts. Absenteeism, we've heard, is up to like 20% in some factories. You're entering new markets are collapsing. You need to make much better decisions much faster. And so you need to scale the way you can improve human performance. And that's what we're focused on, is not that onesie twosie change, but big significant change on the level of the line or the plant all at once. And we're focusing on doing it with people. Because as we talk about all the time, and if this is your first webinar, then I'll say it, but I'm sure those who've been on previous webinars have heard me say this before, something like 72% of the tasks in a factory are still performed by people. Most of Industry 4.0 has been focused on the machine data stream. We're looking at people, and we're trying to get data from people in order to make that kind of step level change that factories really need. So what we do is we create data. How we do it, we have a really sophisticated, really, I think, really compelling technology offering, but we don't think of ourselves as a technology company. We think of ourselves as a data company that drives ROI. If you tell your boss, hey, I want to put in AI, then you're not saying anything. But if you tell your boss, hey, I want to improve quality by 20%, that is saying something, and that's the kind of things that we're focused on. We just had our Series B, and a lot of you guys know in the invitation to this webinar, in the Series B, we talked about AI-powered production. So this is some of the things that we've announced in conjunction with this Series B. We've announced some of the customers we're working with that you can see on left. Denso and Flex in particular are our oldest customers. Some of the people we're working with, some of our partners, we're working with some of the most important and well-respected strategic consultants in the world. And that's because they see Drishti as a strategic tool, not just a tactical tool. Again, this isn't one station, 2 stations. This is the entire system. And that's exactly why you would call up a McKinsey or an A.T. Kearney or a Deloitte anyway. And that's why they're working with us. And then we've got some great investors, including Toyota AI, including Hella. Presidio Ventures is the venture capital arm of Sumitomo Corporation. So you know what a great big manufacturing conglomerate they are. For these investors to all put their faith into us, it's, of course, as an early employee, very satisfying, but it also speaks to the level of what we think we're building here. Last slide for me before I hand it over to Samir a little bit. This is a quote that was in our press release by one of the senior general managers in Toyota Japan. You can read this for yourself, but basically what he's saying is that at the heart of Toyota Japan, where they have, the Toyota production system is a philosophy, it is a way of living. They're seeing Drishti as something that they're believe so strongly in that they're willing to contribute a quote to our press release. And that, in my mind, is a really significant validation of the work that we're doing. And of course, he mentioned this phrase, AI-powered production, which is what kicked off this whole webinar, because we got so many questions. What does AI-powered production mean? So with that, I'm going to hand it over, or actually, Samir, I think this is my last slide, right?
Yep.
Sorry, before I do that, so the status quo of lean is this, that for 100 years, we've seen 3 eras of manufacturing. We saw craft manufacturing, prior to the 1800s, up into the 1900s. Eventually, we saw mass production in the early half of the last century, and that translated into lean or Toyota production system, which we're really still using today. But there's 2 common threads across all of these eras of manufacturing. Thread number 1 is that we're still reliant on people to do the work. That was true then, it's still true now in most industries. And then thread number 2 is we still don't have any idea what people are doing. And as Primo said, you got to stand there with a stopwatch to figure out how to improve your system. And what that speaks to is that data collection has still been highly manual, highly idiosyncratic, and making decisions has been really, really difficult in this environment. So finally, this is starting to change. It's a little bit of hubris maybe, but we think that Drishti's data and video is ushering in this 4th era of manufacturing that we call AI-powered production. So actually, before I hand over to Samir, let's talk a little bit about this story. Primo, as he mentioned, is sitting in our customers, or at least pre-pandemic, was sitting at our customers every single day. And so he got to see firsthand how some of the technologies were being used to solve very specific problems. So Primo, you have a story about an escape defect that I think really illustrates the power of video and data working together.
Right. So had an event where a defect got to a customer, and they came to me, some of the line leadership personnel came to me and said, hey, we have some information about this part, specifically the date and the time when it was manufactured. Is there a way you can help us isolate and locate this video to show how this product was made? And we were able to do just that and actually see the entire process in video format of this given part and show that there was no defect on this part at all. And that information was then communicated back to the customer, where they, of course, were like, well, wait a minute, that's, thanks for letting me know. Clearly, it was not, this defect was not created at your facility. And pretty much that issue was put to rest. The important thing is that prior to Drishti, it would have taken a good 3-4 days to try to replicate and review everything that happened and backtrack and see how was the defect created? First of all, was it created on the line? How was it created? And how can we prevent it moving forward? We were able to do just that in just over 20 minutes. And it was amazing, extremely powerful.
Yeah. So what you're seeing on the screen is a screenshot of our product. To give you a sense of the usability, it's basically like using YouTube. So we are able to define the beginning and ending of every cycle of that particular customer. And then we're able to search and browse. So show me all of the cycles that took place on Tuesday, May 13th, between 3 and 3:05 p.m. at station 2. And with that level of replay, you're able to very quickly get back and look and find the incident you're looking for. You can also take those videos, you can share them, you can send them to your customer if you so desire. You can tag them, you can say, this is an example of something that needs to show up in training. So you tag it for the next training class so that you can show them the video of what took place during training, and they can fix it one-on-one or in a classroom setting. There's all sorts of different things that start to happen when you're able to very quickly define elements of things that are happening on a floor and back every data point by video. And that's a lot more about what we'll talk about in this webinar. Okay, so now let me hand it over to Samir, who's going to talk about what's lacking in lean today?
Yes. So basically, as Dave already said, one of the things that's lacking in lean is the data. So lean is all about identifying waste and identifying muda. But to identify muda, we actually need to know what's going on. And often when you're making hundreds of thousands of parts a day, it's hard to have a full comprehensive picture of what people are doing and what are the challenges they're struggling with and what may be causing the line not to be as lean as it could be. And what Drishti gives you for the first time is a continuous, automatic, and comprehensive data set of human activity on an assembly line. So I want to emphasize the points. It's continuous, it's automatic, and you get it once you turn this on. And since manual activities still make up more than 70% of factory tasks and cause almost 70% of defects on the line, it's very important to know what the people are doing. Primo already told the story of the defect that wasn't caused by the line. He has equally compelling stories of when defects were caused by an associate making a one-off mistake, and sometimes an associate making the same mistake repeatedly because they misunderstood the work instructions. And by using Drishti, you can not only identify these defects, you can actually isolate them, understand what the scope of the defect is, and control how much you need to contain and what you need to do to remedy.
Yep.
So we have plenty of machine data. I'm sure in your plants, most of the machines are instrumented. You're getting, torque data from your torque drivers. You're getting temperature data. You're getting all sorts of other stuff. But the human data is missing. And so you have this big blind spot in the center of your activity in your assembly lines, which is the people. And Drishti is able to shine light on that blind spot for you.
Yep. Next slide.
Yep.
And by the way, to the audience, we have the Q&A and we have the chat. So feel free to post any questions. We are monitoring them and we're happy to address them on the fly.
Yep. So, these days, people may not use stopwatches. They actually go out with iPhone apps, but the principle is still the same. You need to go to the line to observe it, and you have to measure manually. So you have to go stand behind somebody, wait till you feel they're back to their normal method of production, and then click. And actually, experienced industrial engineers take pride in being able to click the stopwatch with one hand and take notes with the other. And they're really good at it, trust me. I would never be as good as they are. But nonetheless, the data isn't sufficient or complete. And these days with COVID, it's hard to get because your industrial engineers aren't even allowed to get on the floor to find out what's going on there. So at the end of the day, we're still where we were when time and motion studies first started, which is measuring something by hand. And what Drishti gives you using our computer vision and AI is, as I said, continuous data and automatically. So, and even more importantly, without any observation bias, right? There is no bias on part of the engineer, and there is no bias on part of the operator working on the line either. The camera is there, is unobtrusive. Pretty much within a week or two of the camera being installed on a line, most operators cease to notice its presence and go back to behaving like they would before.
Yep.
So at the end of the day, what's lacking in lean is sufficient data, and so that you can actually understand what's going on, what are the sources of variability, and what actually you can do to address these issues, right? And where these sources of waste are. And I'll tell a little story before we move on to the next slide. So at one of our customers, they have with the operators, paste a label onto the unit. They assigned 7 seconds for this activity because they tested that it takes 7 seconds. However, if the label doesn't go on right, the operator needs to peel it off, put it back on, and now that 7 seconds becomes 20 seconds. And they found that, or we found, working with them, that this one step was taking an average of about 14 seconds because of all the variability that was being caused by not being able to put the label on correctly. So once they saw this, they were able to design a countermeasure. They built a little jig And now the average cycle time is on that step is down from 14 seconds to 9 seconds. And
Yeah,
there's a clear 5-second gain in efficiency.
and Samir, if I can interrupt, that's exactly what we mean by AI-powered lean. Traditional lean methodology, properly applied, could have found that variance in the label step, but it would have taken a huge manual effort of observing and hoping to catch unbiased activity, hoping that you catch the times when the operator doesn't do it correctly. But when you have a continuous data stream, it becomes very easy to, for example, go in and tag yourself. And within minutes, you can probably have 20 samples of a person putting on a label, and you can start to understand, just conducting your own analysis of the video, is that a variable step or not? Not possible in the traditional lean, simply because you couldn't easily collect that kind of data, and you couldn't do it without standing behind the person and introducing the bias.
Right. And so here's a story of an actual line at a customer. The line's stack time was 288 seconds, but it was not meeting production, even though the IEs thought it should. So we looked at the line, and basically the first thing we realized is that there is actually a spread of times that it takes an operator to actually do the job. So what you see here is a couple of months of cycle times distributed, and so you can see that even though the takt time is 288 seconds and a lot of cycles are around that time, there's cycles going all the way to 700 seconds or even 800. And so there is some cycles that take a really long time. So the observation that we had was, and Dave, if you could just click, the traditional IE is measuring what they consider good cycles. And so they see that the station or the line should meet the takt time, but there's all these long cycles, and there's a lot of opportunity there. And many of these long cycles correspond to repeatable causes. And what Drishti gives you, again to emphasize, is video. Every data point we give you is backed by video evidence. So not only can you know that something is wrong, you can watch the video and see what is wrong. And we can tag this, and in the future, we hope to actually use these tags to train higher layers of AI on top of the cycle time data that we have and the human activity data we have. So we can actually automatically tell you, hey, Joe on station 3 is struggling with that screwdriver again. Mm-hmm. And that's what the power is. So actually, there's a lot of, this is a hidden motor, hidden waste on the line. It's sitting in the tail. It's the data that the normal industrial engineer would throw away because they would believe it's not repeatable. But there's a 3 to 5% production improvement opportunity here. And in fact, actually, this line was rebalanced and reconfigured based on the insight that we gave them. And these changes were realized. And so they actually saw about a 6% improvement when they were done implementing all the changes. Yeah. So this is, go ahead, Dave.
And just to double click on what Samir mentioned, having the video is the critical thing, because you can look at this and you can say, oh, there's a problem in my long tail. Well, now I got to go spend 10, 15, 20, 30 cycles times 700 seconds each in order to figure out what's going on. That's the traditional way. What this customer did here is they watched videos, they watched them in high speed, and whenever someone left the station for, let's say, 20 seconds or longer, they would just tag the beginning and ending of that. Whenever they would see somebody come in and start talking to the operator, they would tag the beginning and ending of that. If the operator came back empty-handed versus holding a tool versus holding a part, they would tag that. So they could go through this incredibly long tail, and it would normally take them forever in the real world if they're working in real time to categorize it. They're able to work in higher speeds, find their Pareto of root causes, and then start tackling the problems. Turns out a lot of their problems caused by missing tools. Well, that's a very simple problem to solve. Very hard to discover that problem with traditional lean methodologies. Very simple to solve once you know it exists.
Right. And I'll just make one more point there, Dave, which is, I think, also important. In the traditional lean methodology, you discover that something isn't working, and now you need to go ahead in time and spend time to find those observations again. With Drishti, you can discover that something's not working and have all the observations you need to actually understand the root cause. So you don't have to wait days or months. Those are 5% of the cycles, or 10% of the cycles in the tail. To collect that amount of data would take you another 6 months. So if you notice something was wrong in the past 6 months, it would take you another 6 months to collect that data. With Drishti, you already have the data. You can go ahead and just take action.
Yep. I'm going to keep moving because I realize it's already 11:30. So how can AI improve lean? How can AI improve lean is the topic next. And the first question is, what exactly is AI? I've had customers ask me, well, AI can do anything you ask it to. It's not exactly the case. AI is basically pattern recognition. And any AI company, that's all they're doing is they're feeding in data where it's really hard traditionally for a computer to recognize patterns, and they're teaching it to recognize the patterns. In our case, the first level of AI we're using, as Samir mentioned, is AI to parse a stream of video to figure out what a person is doing. Very, very simple to say, very, very difficult in practice, because if you're building a unit and you're picking it up and going like this and turning it over and putting in the PCBA and then putting on the cover, that's a highly variable thing. And traditional computer vision would instantly fall apart in that kind of environment. But that's the kind of environments that we're working in. And the purpose, again, we're not an AI company, we're a data company. The purpose is to get data, in the case of that example, to get data on cycle time every single cycle. So how does Drishti work? How do we get this kind of data? We put in on the left, it says we put in a camera in every station. We're looking at the process, not the person. We're streaming that video to the cloud, and we have ways to create different kinds of data. Searchable video, time and motion data, and then descriptive data. Some of those ways are automatic using AI. Some of them are manual tools we give you that let you do time and motion studies, but much, much faster. And then we actually have services where we can do them in bulk, on your behalf. And then I think what's the most engaging thing about Drishti is we send the data back to the people on the floor. I've seen a lot of manufacturing technology where you put in the technology, then you got to hire a bunch of computer engineers or data scientists to make sense of it, or to design apps that make sense of it in your environment. We've built apps all the way from the collection all the way to the apps that let people on the floor who aren't computer scientists, or in some cases, not even computer users very often, and let them use data and use video to make quicker decisions. And that's really the purpose of AI. AI parses large streams of data to figure out what a human being should pay attention to. That's what we do. And then we give it to the human being who's going to make a decision in accordance with the standard lean principles. So traditional lean, episodic and manual data creation, which means you have insufficient data and significant observation bias. Observation bias because the operator knows they're being watched and they act differently. In AI-powered production, it's continuous data creation. It's doing it automatically on your behalf, which means you have data on everything that happens. And at some point, as Samir said, there's no observation bias because people just learn to live with that piece of infrastructure that's helping them do their jobs better. And if we have time at the end, we'll talk about the operator benefits and how operators actually really appreciate having Drishti on the factory floor. I see one or two more questions. I'll get to those questions in a second at the end, but please put in your questions now, and I'll make sure that they're addressed when we have time. Okay, so let's talk about virtual Gemba. Primo, again, you're on the factory floor a lot. I remember being in that factory as well, where you sit. It's a 15-minute walk from where you sit to where production is actually happening. So talk first of all about this idea of remote visibility.
Okay, that's one of the awesome things about Drishti is being able to view the portal, but you don't have to be right there at the line. That alone, one of our latest features is a mobile app that you can also see the portal in your phone, which helps out a lot. A lot of times, the line leaders are not just sitting at a desk; they're moving around. They have to make sure things are happening on their line, making sure things are moving. So the ability to see what's going on basically in a phone has been extremely helpful. On top of that, if they are at their desk, they don't have to be at the production line again. It could be other levels of management that are looking at the line, and they don't have to walk down to the line. They can see the portal right on their laptop. Also, go ahead.
Please continue.
Okay. Also, obviously the information is what it is. We've been talking about this. It's data that is unbiased. It is what it is. If you want to understand why it is what it is, then you dig a little further. You review the videos. A lot of times, industrial engineers that I've worked with, they actually do their time studies in their own offices, reviewing, using the search tool, going back in time, reviewing what was running at a given point in time, date, time frame, line, part number, whatever it is, and they're able to do comparisons. And they're able to take information that previously, without Drishti, they would not be able to do this. I actually had an IE talking. He would go down and try to time when a changeover was going to happen, so he could get some time, the information, and basically do a time and motion study. That was pre-Drishti. Now he doesn't have to do that, and most of the time, let's be honest, he messed up. Either he got the time wrong, or the production line ran longer, or actually ran less because they ran out of components, and so instead of at 2 o'clock, it actually went down at 12, and they already changed it over to whatever, another part number that he wasn't even planning on, so he would have to wait for the next time that ran. So there's a couple examples of why the virtual Gamba is extremely helpful.
Yeah, this is kind of an aside, but one of our customers is very meticulous about benchmarking everything. They benchmarked something like 33% of an IE's time is spent just gathering data. And one of the reasons they got really excited about Drishti is that we gave all that time back to the IE. Mm-hmm. Do you want to talk about social distancing for a second? Actually, I can talk about this one. So basically, a lot of our customers have come to us in this time of COVID saying they're using Drishti to take the people who are normally hovering around the operators on the line and letting them instead work using a computer from some safer place. So just like I'm here at my house, as opposed to in the office sitting next to Samir, the engineers, the supervisors in some regards, the trainers, plant management, quality people, product designers who might normally have to travel to the factory, they're all actually using video and Drishti to do their jobs. And that ends up keeping the operators safe because social distancing is a population density problem. The fewer people on the line, the safer everyone is. And so that's certainly not something we designed for, but it's a really nice byproduct of what we've got. So speaking of product designers, Samir, do you want to talk about the NPI use cases that we're seeing?
Yeah, absolutely. So one of the things that COVID has also brought upon us is that designers and IEs cannot travel. And so if your process for a new product is being developed in your design center, then it's how do you get it to the factory? Right? So we have a couple of customers who are actually trying this out right now. They are building the process out in their design center in Japan, and then transferring the videos to their facility in North America. And the IEs can actually watch the operators learn the process, see what issues they might face, and actually address them in real time. And so this is becoming a really powerful use case that we see. We saw the potential for this, but again, COVID has brought home the fact that travel may just not happen. And so without travel, you're still able to transfer knowledge and do it, in fact, better because you don't have to move people. The entire team can see what's going on.
Yep.
Feedback we got from the customers actually was that product designers love to see how the product assembly is happening because that allows them to design better for manufacturability. So that's something that, again, just being able to show the line to people who would not typically see the line makes a big difference as well. Yeah. And finally, we are seeing this at customers. We have now started to see outsourced teams of industrial engineers who can actually monitor the line and collect information from it without being physically present. So we see this potentially as a future state of manufacturing where you would have centralized industrial engineering hubs that will actually not be co-located with the factories, but will be able to see what's going on in the factories and actually transfer knowledge, collect knowledge from different factories and transfer knowledge between factories. So we see that as a very powerful use case for efficient knowledge transfer as well.
In practice, there's a really interesting idea that we're starting to see some customers experiment with, where they'll have some team in India or Philippines or Indonesia where things are a little bit lower cost that will analyze videos from the day's shift while it's overnight here. They show up to work daytime, their time. They analyze videos, they analyze data. They send instructions back to the line so that when they show up the next morning, they have their marching orders. They know what the problems are, and they got a sense of what they should be doing. So it lets you, again, this decoupling lets you take the traditional methodologies of lean and just do them a lot faster and a lot more effectively because you're no longer constrained by space and time. And I sound like a Star Trek novel. I'm sure there's one or two of them behind you, Samir, but that's kind of what we're actually doing and why we get excited about this concept of AI-powered lean, AI-powered production. Okay, so we have talked about a lot of use cases. I'm not going to read every single thing that's on here, but one of the things that customers kind of asked us, because customers will always say, can you solve problem X? And the answer is yes. I mean, not every problem, but a lot of problems. And there's always a little bit of skepticism about why so many use cases are supported by this technology. And the quick answer is because this data has never really existed at scale. It's always taken so long. So if I've got a Pareto of 10 causes of problems, I would only, in the traditional methodology, have the capacity to go after the high runner, to go after the one that is causing the most problems. I would never have the capacity to go after problem number 7 or 8. But now I do, because all the data is there, it's sitting there waiting for me. And so as an industrial engineer or as a quality engineer, I can finally tackle that long tail of problems that have always been nagging at me. And there's a reason why a company like Toyota is going to be in our press release, or back in February, a company like Denso issued a press release talking about the work that they're doing with Drishti. The reason why is because we're taking what they do and we're enhancing it and fitting in with their existing workflows in a way that makes them just, you know, the cycles go from like this to like this, faster and more efficient. So the last thing I want to talk about is the operator point of view, because this is the thing that always comes up. What do operators think about when they show up to work one day and there's a camera over their head? So Primo, why don't you start, since you work with the operators day to day, they know you very well, you know them very well. What do you say when an operator says, what's that camera doing there?
First and foremost, I always talk about what the camera's focused on, and the camera's not focused on the individual. They are focused on the work itself. Once I not only say that to them, but I also show them in the portal, my next question is, yeah, but can you hear me? We have no audio in any of our videos, so we can't hear what the operators are saying, nor do we want to hear what they're saying. Our focus is the work itself. And honestly, once I say those two things, the operators are good. Most of them have stepped away and go, good, okay. And then we move forward. Real quick, I want to share a story that I was able to be part of, I guess, in a way. It was communicated to me in talking to a line supervisor. This one given day, there was a part that had reached the assembly, the final assembly had reached the end of the line, and he had noticed a missing component of that assembly. And when he backtracked to see where the component was being installed, he realized it was at a station where we had this operator who was extremely, extremely proud of her work, very diligent, an ideal operator, right? So he approached her and said, here's the situation. We're missing this component. It's usually installed. It is installed on your station. Let's go back and let's take a look at the video. Right away, she was like, what? I missed a step? No way. No, there's just no way. So he went ahead and reviewed the video. And upon review, it was what they found out was the operator, as she was installing this one particular component, or thought to be installing it, she reached out, and as she was reaching out for the component, instead of grabbing the component, she adjusted the bin that the component came into, or was in. And in doing that motion, she thought that she had grabbed that part and installed it. But instead, she had just adjusted the bin and moved on with the process. So in reviewing the video, she clearly realized I missed that component. I did not install that component. And she was actually pretty humbled by this whole thing. She never thought she would ever be, that something like this would happen to her because she was so diligent with her process and her technique and her following standardized work. But more importantly, she not only did she learn, but she appreciated the way the line supervisor approached her about it. And so at that point, it became think of it as a training opportunity. And it was quite positive. And she walked away knowing that the supervisor was not out to finger point. They were out to point out that, hey, we missed a component on this assembly, and obviously the customer cannot receive that part. So there was a great example of how powerful Drishti is with the ability to view the videos and what's actually happening out on the floor.
Yep. And I see a couple of questions that we'll get to. By the way, if you have questions, because we're getting close, about things that you're still concerned with or don't understand about Drishti, please put them in the Q&A so that we can be sure to answer them in the about 10 minutes that we have left. The flip side of that, though, of your story, Primo, is this idea of protecting the operator when the operator does the right thing. And we've seen this a lot, usually on the line. I've seen this personally in my own eyes when touring factories. There becomes emotion gets involved. The supervisor knows there's something wrong. Supervisor has to make a snap decision about what the problem is and how he's going to fix it or how she's going to fix it. And that can cause emotions when operators know they did something right, but if it had no proof. So one of the things that we've really seen operators start to appreciate is the fact that there are protections. There's proof. There's a trail of truth that demonstrates that they know their job, that they do their job right, and what the real fault or the real problem really is. Oh, I've been telling you for weeks that this gun's jamming once out of every 150 times or so. Now I finally have the proof. That's the kind of thing that operators really start to appreciate. That's the first one. Second one is they actually get to contribute back. Because if I have an idea of how to improve my process, and I know that the IE is having continuous cycle time created, it's very easy for me to say, hey IE, can we try it for this rotation this way? The IE doesn't have to do any extra effort. The work gets done, the data gets created, and then you can see, oh, it turns out that operator's idea really works, and they can contribute that value back to the company. And ultimately, especially today, but anytime, people want to keep their jobs. And Drishti represents an investment in the people, and the people get to create more value beyond the work that they're doing and contribute their knowledge back to the system, which we know operators really, really appreciate.
That's correct.
So Samir, we got about 5 minutes left before we do the Q&A. Do you want to talk about ROI?
Yes, I'll talk about ROI, and I'll quickly introduce a concept that we haven't talked about earlier, which is Drishti essentially has multiple tiers of engagement with its customers. At a basic tier, we collect video from your facilities and store it. And even with that, we see significant ROI at our customers. So you can use the stored video to root cause, as Prima mentioned earlier. You can use it to do new product introductions, to improve process design. Another very powerful use case is training. Traditionally, factories with high churn have always struggled with training. COVID has only brought that home even closer to their heart, because these days, not only are you seeing churn, you're often seeing high absenteeism and variable demand. So you have to move operators across stations. So training operators faster is a significant use case that Drishti's video enables. Mm-hmm. Then if you add to this the AI layer, which we sell as the flow package, this is automatically creating cycle time data for your customers. You can, in real time, identify bottlenecks, imbalance in variability, understand what is causing your line to be slower than you would expect it to be on any given day or over some period of time. Also, as we said, we automatically generate data for you, so you can do faster and more efficient Kaizens. One of the things that we heard from our customers is that using Drishti's data and knowing what we can expect when we go out allows them to do the Kaizen right the first time. So they don't actually struggle with implementing changes and watching productivity drop. they can actually gain the advantage of the Kaizen immediately.
Yep.
The other thing that we do, and I'll stop with this one, is if you already have an efficient line, we help you stay efficient, stay optimal in a much better and much cheaper way. Mm-hmm. So that's something just to think about. It's not just about getting you the efficiency, it's also about helping you stay efficient and stay optimal.
Yep, cool.
So Dave, I'll pause here and then we can take questions, I think.
Yeah, so there are a couple of questions. I'm going to answer one of them right now and then one of them on the next slide. So the question is, are you planning to show a demo of how Drishti works? Here's the honest truth. The truth is that we've grown so fast and have been so busy servicing customers that we never built out a demo portal. So we can't show a demo without an NDA in place because we'd be showing our customer work. So if you want to see a demo, what you need to do is just either go to our site and request one, or just say in the chat or in the Q&A, hey, I request one, and we'll have someone reach out to you. But unfortunately, we can't show too much of it on the screen today for that reason. Okay, so the question next is about training time, it's about prep time, it's about IT. And then the question about cycle times we'll get to in a second. Okay, so Samir, do you want to take this, or you want to do a quick conversation about deployment?
Now, why don't you go ahead and take this,
yeah.
And then, yeah.
Okay, so basically, the things you need to know about deployment is it's fairly simple relative to most of the complex installations you would do on a factory floor. Drishti is a camera, and then the camera feeds into the cloud. So all the magic's really happening in the cloud. So what we end up doing is coordinating an installation of cameras during a break or during a lunch or maybe on an overnight period where we go in, we put in the camera, we connect it, and then by the time people show up the next day, the data is already flowing. Some of the things like the traceability and the video storage and the ability to tag and do time studies, that starts on day one. Other things like the AI might take some time to develop, and then sometimes could be days or weeks, depending on the nature of the production. And we can answer that more precisely because it depends on volume, depends on unit type, a couple other different things. In terms of IT requirements, I think it's 2 megabits.
I can jump in there, take that one, Dave. So, okay. Yeah, so basically just to add to what Dave said, one of the things we've done with COVID is actually develop a self-install kit. So we no longer have to show up to install. We can ship you cameras and you can install them yourself. We installed, besides the cameras, we need a firewall so that we can actually transfer video and connect and manage the cameras. And we also install a Linux appliance that allows you to manage traffic. The bandwidth requirements are pretty reasonable. We can go into that detail later with anyone who's interested. But overall, with the existing internet connection, we can piggyback and get there. And there's very little management effort in your end that's needed.
Great. So yeah, the next step is just simply to reach out, send a message on Zoom in the Q&A. I think those are private, or visit our website, and we'll set up a demo as soon as we can. Last question I've got here, and I'll just open the floor to questions now. And I think we'll do about 2 more, and then we'll have to end it because I know we're approaching the top of the hour. The first question is, what is being used to determine the start and end of a cycle when you're parsing the video feed? Samir, do you want to take that?
Yeah, sure. So there's several different ways we can do this depending upon the process. So for example, if you have bench assembly, then we mark the start of the process as when the unit enters the work area that you designate for us. And we mark the end of the process as when the unit leaves the work area. But for moving lines, for example, we may have a different paradigm. So we believe that there's a few paradigms that cover every station that we have seen so far. But if you think that this does not cover your use case, we're happy to work with you to understand that better as well. Most typically, as I said, it will either be when the unit enters the work area or when the operator performs the first step on the unit.
Yep. Cool. And the last question that we'll answer today, one of the things this company struggled with is conducting Kaizen events during COVID. Does Drishti help with that? So I'm going to imagine the scenario here. In a lot of the companies I've seen, there's like a central Kaizen team. It's like a SWAT team that sits, let's say, in Detroit and flies out to all the factories and goes in and fixes everything, then goes off to the next one, kind of like the A-team. Now, suddenly COVID hits and you can't fly your Kaizen team anywhere. They're sitting at their home base twiddling their thumbs. What we've seen some customers do is use Drishti to have their Kaizen team stay productive remotely, which is, a good first step. The next logical step really is to say, well, if I can use all this video and feed it back to my Kaizen team, then I can change the nature of a Kaizen. Maybe I don't need that intense 5 days. Maybe I don't need a SWAT team. Maybe I can have a team of people that just knows how to do process improvement. And instead of doing one big event per quarter, can do continuous improvement over time. And like Samir said, with that post Kaizen monitoring, so that when things start to slip, because they inevitably do start to slip, the Kaizen team can come back to it and solve the problem. So, I think just to round out to, I think there's, just to round out to where we started, this notion of AI powered lean versus traditional lean versus AI powered Kaizen. Traditional lean, we don't believe that the methodologies of lean or the practices or the philosophy of TPS, we don't think that there's anything wrong with that. Fundamentally, we believe that lean is the right way to run a factory. What is different about Drishti is taking that and empowering the people who are making the decisions with far greater data and far greater visibility than they've ever had before. And actually, I remember one of Primo's colleagues, Dahlia, when I first met her and first showed her the demo sitting in a Starbucks in San Jose, she got really excited because she was a former IE. And she says, it would take me a week to get the kind of data that you guys just have there sitting for me. And she's just thinking all the things I could do to improve the process if I didn't have to spend all that time with the stopwatch. And that's exactly where we believe the industry is headed, and we believe we're going to help our customers get there first. Thank you very much, everybody. Join us next time for the next webinar, where get there a few minutes early, and you'll be able to do Would You Rather as well. Thank you very much.
Thank you, everyone. Thanks for joining.